So today we're going to start talking about actually solving polynomials, and it is important to note that you have solved some polynomials before. Linear functions are polynomials. Quadratic equations are polynomials. So the methods that we used to solve our quadratics and the methods that we have used to solve our linears are still going to be methods that we use. So that's something that I want you to keep in mind as we're going through and talking about solving polynomials over the course of this week. So first we're going to start with one of the first ways that we learned to solve quadratics, and that was solving by factoring. So this is the first way, one of the very first ways that we learned to solve quadratics was to look for its factors, get it factored, and then set each factor equal to 0 and solve for x. All right, so let's take a look at solving polynomials by factoring. So we have discussed anytime you solve a quadratic by factoring, it has to be equal to 0. And that's going to still be the first step for solving any polynomial by factoring, is make sure that the equation is equal to 0. If it is not equal to 0, then that 0 product property doesn't work and factoring doesn't do us any good. So we do want to make sure that we are actually equal to 0 and not something else. So that's always going to be our very first step. So let's say this is the equation that I'm actually looking to solve. Things we want to remember is if it is to the third power, then it has to have 3 roots, 3 solutions. So that's really kind of, when you're solving polynomials, you always want to know how many solutions are you looking for, because that's important. So I know I should have 3. So I'm like, oh, this is not equal to 0. So I'm going to subtract 7 from both sides. And I've got x cubed plus 8 is equal to 0. And so now that it's equal to 0, I can actually go through with the next step and I can factor. So now we want to factor this polynomial. So I want to identify what type of polynomial it is. It's a binomial. So I only have a couple of ways I can actually factor a binomial. If it's a binomial, the only way it can be factored is if it is a perfect square minus a perfect square, a perfect cube plus or minus a perfect cube, or if it has some kind of common factor. So there's no common factor, and it's not a perfect square. So really the only chance I've got is if it's a perfect cube plus or minus a perfect cube. And it does happen to be. X cubed is a perfect cube, and 8 is 2 cubed. So that's a perfect cube. So we can factor this one. It's a sum of cubes. So we need to remember what our pattern for solving a sum of cubes were. If you remember, we start with a binomial, and then the binomial is getting multiplied by a trinomial. So to do the binomial, we just take the cube roots. The cube root of x cubed is x. The cube root of 8 is 2. To figure out our trinomial, I need to square both of those. So I get x squared, and I get 4. And to get the middle term, I just multiply the 2 of them. And remember, this is the point at which we apply our SOAP. SOAP is very important during this pandemic, and it's going to be important for factoring sums and differences of cubes. So I want to do the same sign. This one was positive, so this is going to be positive. The opposite sign, so it's going to be negative. And this one is always positive. So now I have factored this equation. And then, as always, when solving by factoring, we set each factor equal to 0 and solve for x. So I'm going to get x plus 2 equals 0. And I'm going to get x squared minus 2x plus 4 is equal to 0. So when I subtract 2 from both sides, I get x is equal to negative 2. So there is one solution. And this is a quadratic. And when we were factoring these, we did discuss that sum and difference of cubes, we always get a linear factor and a quadratic factor. And it's because this quadratic factor doesn't factor anymore. It's always irrational or imaginary. So that means I don't want to bother with any other method other than completing the square or quadratic formula, because this one's not going to have a rational answer. So I'm just going to hop right into, I'm probably going to get it in vertex form actually. So x squared minus 2x plus something is equal to -4. I moved it over to the other side. Half of -2 is -1, and -1 squared is 1. So I got to add 1 to both sides. And then this is going to be x minus 1 squared is equal to -3. And when we take the square root of that, I get x minus 1 equals plus or minus I on the square root of 3. And then I can just add 1 to both sides. So I get x is equal to 1 plus or minus I on the square root of 3. That's 2 roots. Remember, it's the plus or minus. And then I have x is equal to -2. So that gives me 3 solutions. I found all 3 of the solutions that I'm looking for, and therefore I am done. Now let's try to factor or solve another polynomial with a different factoring form. This time we're going to focus on a quadratic type of factoring. So remember, if you have a trinomial, so it has 3 terms, we want to check and see if it's a quadratic type. To be a quadratic type, you have to have an even highest power, and then that middle term needs to be half of that power. So if it is a trinomial, your first term has an even power, and the second term is half of that power, then it is a quadratic type. And by being a quadratic type, that means we can just use the same old factoring rules that we used when we solved quadratics. So when I'm looking at this one, I'm just going to take my A and my C, and I'm going to multiply them and get -24. And I want to find 2 numbers that multiply to equal -24, but add to equal -5. So -8 times +3 would multiply to equal -24, but would add to equal -5. So that means that in the area model, the inside of the area, before any common like terms were put together, was originally 2x to the 4th, -8x squared, +3x squared, and -12. Because remember, these 2 terms aren't ever alike, but these are the 2 terms that always end up getting put together when you use that area model. So when we were looking here, what did these 2 have in common? They had a 2 and an x squared in common, and these 2 had a 3 in common. This column has an x squared in common, and here we have a -4 in common. And so that means that this is going to factor to be x squared minus 4 times 2x squared plus 3. Now, sometimes after you factor once, it can still be factored. Notice that this first factor here is a perfect square minus a perfect square. So that means that it will actually factor to be x plus 2 times x minus 2. But 2x squared plus 3 doesn't actually factor anymore. And now we have it in its factored form. It was equal to 0. As always, when solving by factoring, you have to make sure that it is equal to 0. And now we just want to set all of our factors equal to 0 and solve. So x plus 2 equals 0, x minus 2 equals 0, and 2x squared plus 3 is equal to 0. So here I get x is equal to -2. Here I get x is equal to 2. And this one is another quadratic, but I don't think I'm going to end up having to use the quadratic formula because it just has x squared in it. I should be able to just get x by itself. So x squared is equal to -3/2. It's negative, so it's definitely going to be imaginary. And when we take the square root, x is going to be equal to plus or minus. That's how I get those other 2 answers. Notice it was to the 4th power, so we have to have 4 roots. If it's to the fourth power, I got to have 4 roots. So here's 1, here's 2, and this is going to be a plus or minus, so it's going to give me 2 more. Don't forget it's got a negative, so it's going to be I, and that way we don't have the negative inside anymore. And this one is going to need to have its denominator rationalized. Don't forget, it's the square root of 3 over the square root of 2, and we can't leave that square root of 2 in the denominator. So we're going to multiply the top and the bottom by the square root of 2, so we get the square root of 6 over 2. So I square root of 6 over 2. If you did it with the quadratic formula, you would get the same thing. If you did it with the vertex form and completing the square, you would get the same thing. So it doesn't matter which quadratic method you want to use, it's always going to work either way. But I do get 4 roots. You want to make sure the number of roots has to match your degree. That's a fail-safe way to always check and make sure that you got everything you were supposed to have.